Hey everybody, we are going to add and subtract rational expressions. Okay, so let's talk about this for just a second. So rational expressions are just like any other fraction. When you add and subtract them, you have to have a common denominator. So if I'm adding two fractions that have the same denominator, I can essentially add the numerator, keep the denominator. Same thing happens if I'm subtracting two fractions with the same denominator. I can subtract the numerators and keep the denominator. If they do not have the same denominator, then you have to get a common denominator, right? So in this case, my denominator is c and d. The way I would do that is I would multiply this fraction by d over d, and then I would multiply this particular fraction by c over c, giving both of them a denominator of c times d. Then from there, keep the denominator and add together your new numerators. The same thing happens with subtraction. The only difference is you're going to subtract instead of add. That would be the same for any fraction in the world, even if your fraction has x's in it. So let's do some examples so I can show you how that works, okay? So what the directions will say something similar to find the sum or difference. That just means go ahead and add or subtract. And let's look at a few examples of how we might see this in our work, okay? So example 1. Let's start out pretty simple. Let's say I have something like 7 over 4x plus 3 over 4x. That's what I want to add. So remember, I'm simplifying an expression, meaning there's no equal sign. I'm just simplifying this and combining these together, or I'm adding them together. So these have the same denominator, so I'm going to keep that denominator. I'm going to add my numerators. 7 plus 3 is 10. So that would give me 10 over 4x, right? Naturally, I would simplify that. I could simplify that by 2. So that would be the same thing as 5 over 2x, and that would be my final simplified sum. Excuse me, this is a sum, all right? Sometimes you can have like a binomial in the denominator, so let's look at an example like that. So let's say I have 2x over x plus 6 minus 5 over x plus 6. These have the same denominator. The denominator is x plus 6. So since they have the same denominator, I can go ahead and in this case subtract my numerators. So that would give me 2x minus 5 over x plus 6. I can't combine these. 2x and 5 don't combine. They're not like. So I'm going to have to leave them that way. And then I'm finished. There's nothing else I can do to that particular expression. Okay, let's do some that don't have the same denominator. So let's see. I'm going to add, let's do 7 over 9x squared plus x over 3x squared plus 3x. Now I can tell right away I'm going to move this camera up a little bit. Okay. These do not have the same denominator. I can see that. Now what I want to do is I'm going to go ahead and factor these denominators. That way I can see how I can best get a common denominator. Okay. So now 9x squared, that's pretty factored. I think I'm going to leave that one. But I'm going to factor this one. So that would be x over, there's a GCF of 3x. So that's 3x times x plus 1. Okay. Ooh. Now, let's see. I can think of 9x squared. Because of the way this factored, I'm going to kind of rethink this 9x squared is what I'm thinking. You know, or, you know what, I might just keep it 9x squared. No, I'll keep it 9x squared. I'm going to do that. What I'm going to do is make these two match. Yeah? So he needs an x plus 1. So what I'm going to do is multiply this guy by, let's see, x plus 1 over x plus 1. Now, the reason I'm doing that is because I want to multiply by the number 1. So I'm multiplying by the number 1 because multiplying by the number 1 doesn't change anything. But I'm going to use the number 1 as x plus 1 divided by x plus 1. That way, I'm still not changing the value of anything. And then here, let's see who's missing over here. So I need this to be the same as this. So they both have an x plus 1. They both have a 3x, but this needs another 3x. So 3x over 3x. Now, what that's going to do is make this denominator 9x squared times x plus 1. And now this denominator is also 9x squared times x plus 1. That is absolutely fantastic. So what this actually means is that I have 7 times x plus 1 over 9x squared times x plus 1 plus x over 9x squared times x plus 1. This is great news. Now that I have the same denominator, I can add my numerators, keep the denominator. Fantastic. So in my numerator then, I'm going to have 7. I'm going to distribute that, if that's okay. So 7x plus 7 plus x divided by 9x squared times x plus 1. Let me go ahead and simplify that. I'm kind of out of space, so I'm going to squish it on the bottom. Okay, so we end up with 8x plus 7, right? These are like, divided by 9x squared times x plus 1. And that's my simplified fraction right there. Let's see. Looks like that's going to work. We are set. Now, I do want to make sure this doesn't equal 0. So let me go ahead and notate that. So, and I don't want to equal 0. You know what? I'll do it on the next one. Let me do it on the next one. Okay. All right. Let's see. Example 4. Let's do it. Example 4. All right, let's say we have x plus 2 over 2x minus 1. Oops, did I say 1 or 2? It's 2. 2x minus 2 minus negative 2x minus 1 divided by x squared minus 4x plus 3. Now, to add any two fractions, I have to have a common denominator. I'm going to go ahead and factor these so that it's easy for me to find the common denominator. Okie doke? So let's see. X plus 2, I'm going to leave that. I don't need to change my numerator. My denominator has a GCF of 2, so that factors to 2 times x minus 1. Minus, and then I have negative 2x minus 1 in the numerator. And then I'll factor my denominator. X times x gives me x squared. I need two numbers that multiply to give me 3, add to give me negative 4. So I'm going to do negative 3, negative 1. Now I'm ready to set these up so I have a common denominator. Okay, so they both have an x minus 1. He needs an x minus 3. He needs a 2. Okay, so x plus 2 over 2 times x minus 1. He is missing this factor, x minus 3. So I'm going to go ahead and multiply this by x minus 3 over x minus 3. And then we're subtracting, and I have negative 2x minus 1 over x minus 3 times x minus 1, and he was missing a 2. Let's go ahead and multiply that by 2 over 2. Now, when you do this, here's some interesting things to remember. These binomials are together forever. So these are actually in parentheses. Whether they are written or not, you might need to just think of it as being in all those binomials being in parentheses, okay? So when I put these together, right, I'm going to have to multiply these two binomials together. So x plus 2 times x minus 3 is going to be x squared minus x minus 6, and all that is divided by 2 times x minus 1 times x minus 3. Then I'm subtracting this. Now I'm going to have to distribute, right, because this is a monomial times a binomial, so I have to distribute. So that gives me negative 4x minus 2. And all of that is over 2 times x minus 3 times x minus 1. I want to take a minute and make sure my denominators are the same. If they are not, I just need to go back and fix it. Okay, so my denominators are the same, so I can do my subtraction. So when I subtract my numerators, I have x squared minus x minus 6. Don't forget to distribute this minus sign because I'm subtracting a binomial, so I need to distribute that negative. So that'll be plus 4x plus 2. And all of that, let's maintain that factored denominator. Okay? I'm going to combine like terms very, very last. I have some like terms I can combine up here in the numerator. So I have x squared plus 3x minus 4, and that is on top of 2 times x minus 1 times x minus 3. Okay, I'm wondering if I can simplify this anymore. Now there's no way for me to really know that unless I factor the numerator, so I'm going to go ahead and factor that numerator. So let's see. X times x is x squared. I need two numbers that multiply to give me 4, add to give me 3. Ooh, you know what? If I do positive 4 and negative 1, that would give me that negative 4 and the positive 3. And that would be 2 over x minus 1 times x minus 3. Oh, I see it. Oh, do you see it? These two cancel out. That's fantastic. So I have x plus 4 in the numerator divided by 2 times x minus 3. That's my final fraction right there. Now I want to make sure, so since these canceled out, you see how they canceled out? It's really important that I make sure that that wasn't actually a 0. Because if it was a 0, then I was dividing by 0 and I can't cancel it. Okay, so I am going to make one caveat on my answer. I'm going to make sure x does not equal positive 1. And the reason I'm doing that, right, is because if x was positive 1, then I accidentally would have divided by 0 here. That would be bad. Now, a lot of people ask why I don't have to notate that for this guy, for x minus 3. You don't have to because he's not canceled out. I just want to make sure that something I canceled out wasn't actually a 0. Because if you were the audience member and you only saw this, you wouldn't know that x could not be 1 unless I gave you that caveat, right? Now, if you saw this, you would know, but not if you saw this. So I have to make that caveat. Anytime you cancel something out, make sure it doesn't accidentally equal 0, okay? And let's see. Let's do a complex fraction. Guys, and I'm going to do this on the next page just because I want to make sure that I have space. Because I like to write really big. I don't know if you need it on the next page, but I will. So I'm going to do it on the next page, okay? Excuse me. We're on example 5, I think. So let's do 5 over x plus 4, that'll be my numerator, divided by 1 over x plus 4 minus 2 over x. Okay, so let's remember what this means, okay? So before I rewrite this, and I was going to rewrite it, what I am going to do is, do you see how this is subtraction here? I want to go ahead and try to get that to have a common denominator, okay? Because it's just going to make my life better. I want it to be a fraction over a fraction. That's really what I want. So let me go ahead and get a common denominator right here. I'm going to do that first, okay? So my numerator stays the same. I'm happy with him. No issues there. But I'm going to take my denominator and go ahead and get a common denominator. So I'm going to multiply this by x over x. And then I'm going to do this guy times x plus 4 over x plus 4. Now, note to self, all of these binomials are actually in parentheses whether we write them or not, because binomials belong together, okay? All right. So that's going to give me a numerator of 5 over x plus 4. Now my denominator is x over x times x plus 4 minus 2x plus 8 over x times x plus 4. And I'm going to simplify that down because remember I'm trying to get one fraction in this denominator. Okay? So I have 5 over x plus 4 divided by, you would distribute this negative, right? So that's negative 2x minus 8. And then I'm going to combine these two together. Okay? So x minus 2x is x. No, it's negative x minus 8 divided by x times x plus 4. All right. Now, let's talk about what it means to be a complex fraction. It means division. So this right here is the same thing as 5 over x plus 4 divided by, right, divided by negative x minus 8 over x times x plus 4. And we know that division is the same thing as multiplying by the reciprocal. So this is actually 5 over x plus 4 times x over x plus 4. X times x plus 4 over negative x minus 8. Now that is not bad at all because I can see that I have the same factors in the numerator and the denominator, so those simplify away. And I have 5x divided by negative x minus 8. And there you are. And to be honest, this may seem like a lot of work, but if I had an equation and my equation started out with this fraction, I'd really rather deal with this fraction once I get down to solving. So it's really not that bad a deal. And that's how you add and subtract rational expressions.